Um, Welcome back. I would like to share my screen right now, session 3, part 2. This is rather close to your generation. Your generation is quite conscious, environmental conscious, and diet and weight conscious. You are extremely active and considerate in terms of your well-being, which is very nice. We look up on, we consider you as a role model most of the time. The question is, will exercise help in weight loss? So what I'm going to do, my statement is this: exercise reduces the weight. Exercise reduces the weight. I could potentially have my setup. My setup is going to be simple. I'm going to have two groups, and I'm going to take a look. I'm going to actually ask them to exercise, all of them. The 2,000 and 2,000 people that I'm going to select, and I randomly said 2,000, it could be 400. I'm asking them to actually exercise. And then I'm going to take a look at their weight loss. Now, if there is no difference in this and basically achieving the objective that is that I see, I'm going to actually say that this is a null hypothesis. Exercise brings the weight down. I can see from the data that it is happening, and I also see that there is no significant difference irrespective of what the samples I'm going to take, and that's why we call this null hypotheses. On the other hand, you could have alternative hypotheses, and that is exercise does not contribute to weight loss. And you could potentially set up an experiment and either prove it or disprove it. We get there. But at this time, I wanted you to keep in mind that you need to actually see what the input is. Exercise, um, how much? Did you talk about calories lost during the day? You didn't talk about gender. If you take a look at the gender, does that actually have an impact on the weight loss? You didn't consider that. Did we consider the diets that these people have right after the exercise? You need to actually have those information in your experiment in order for you to make a meaningful conclusion. If you simply say exercise reduces the weight, actually, it has been shown that is not the case. Mainly because when you exercise on treadmill, you feel more hungry and you go and you actually eat a lot. Versus someone who is going to feel hungry and goes and drinks water instead. So the diet you have after your exercise is actually important. And then, of course, depends on the type of exercise that you have. The type of exercise depends on on your mental and physical health. If you cannot basically jump, then that's not going to be part of the game. So these are the variables that you need to consider. You could potentially start from a small scenarios, simple scenarios, but to be more effective as a domain expert, you need to consider them in general. Daisy and basically petals. The claim is all daisies have the same petals, the same number of petals. So if you take a look at this, what am I going to do? I'm going to actually collect different samples of daisies, and then I'm going to count their petals, this sample and this sample, and I see that they are 35 petals per daisy, right? So I can see that some of them are 34, some of them are 36, some of them are 35. That's how I'm going to say that this seems to be a null hypothesis, because I see that the two samples do not differ significantly, okay? Question, again, as I'm trying to actually alert you to the fact that the questions coming at you are actually questions that are supposed to be thought-provoking. And some of them you haven't even taught prior to this session possibly, but I need you to start thinking about this. You need to be a critical thinker. You need to be curious. And those curiosity and critical thinking are going to actually help you to develop your brain and advance in your growth as the years go. And besides, if you are hired, you need to actually have that kind of critical thinking in the process so that you could potentially assist with the project assigned to you. Here is the question: the number of pets and the number of people in the family. The statement is simple. The question is simple. Does the number of pets depend on the number of family members? The positive way of saying this statement is the number of pets does not relate to the number of people in the family. I simply said does not relate. When I say does not relate, I'm actually trying to create what we call a null hypothesis. Does not create, does not depend on the number of families. So what I have to do, I'm going to have taken samples across US or across globe. I'm going to take a look at families who have pets and then count the number of people in their house, not left for a different city or a different job, in the house, living together, and the number of pets that they have. And then I'm going to say that the number of pets does not relate to the number of people. So when I take a look at that samples that I have, and I really see there is no relationship between the sample A I have, the people in sample A that I have, and the people that I have in sample B, and I have another way of stating that this is a null hypothesis. What am I saying? I'm saying that if you take these samples randomly across US, for an example, and if you count the basically number of pets and number of people inside those samples, you see no relationship here, you see no relationship there, and therefore these two samples don't seem to be significantly different. So either you look at it that way, two samples are not significantly different, or you can say there is no relationship between the number of pets and the number of people in the room, and that's how you're going to actually begin thinking that this might be a null hypothesis. As a matter of fact, we do have people who have more than one pet. So this wonderful person has a cat and a dog, and that means 2 to 1. Right? So you need to be very careful. Another question is, you could potentially ask a few questions here. So experiment was simple right now, but you could say, is this a single parent family? Whether divorced, widowed, doesn't matter. Is this a single parent family? Because a scientific exploration has shown that the single parent family really like pets in the house as companions. So that's going to help a lot. Do they have small children? The age of the people in the household is going to be an important factor. Make sense? So you need to ask these questions. Does the light have an impact on the growth of the plant? That's the question you have. That's the curiosity. That's the curiosity you have. That's kind of a gut feeling you have. You say, yes, it does. Plants need sun. Plants need basically special rays to grow. So I think light has an impact on this. That's your statement. Lights have impact on plants growth. So what do? You're going to have two samples in front of you, 1,000 plant on this, 1,000 plant on this. You're going to shine basically light on them. And then you can see that both plants, both sets of samples have shown growth, except perhaps one which became rotten. And therefore, you are going to declare that these two sets are not significantly different. You could also rephrase your statement, but you can say, okay, let me actually examine something differently. This time, I'm going to have two samples. One sample is going to be shining the light, and the other sample is not shining the light. So you're going to basically examine that and rephrase your statement if you must, okay? What are the parameters? What are the variables? The intensity of the light, of course, the type of light you're actually shining on the plant. The type of plants are going to be important. And if you kept them constant, this is what we call controlled variable. If you kept the same plants in sample A and same plants in sample B, same lights in sample A, same lights in sample B, you actually have constants, plants and constant lights, and these are controlled variable. What is the input? The input is going to be the light. What is the output? You measure the growth by perhaps centimeter. And that's how you're going to examine your scenario. Apples fall from tree. Apples fall from high altitude to lower altitude. You can say that. But the problem with this, obviously, I can tell you and I can take you to a zero gravity room NASA has, where when you leave an apple, it's not going to fall. So you could potentially have a counter argument for me. You could potentially set up a different experiment where you are going to reject my null hypotheses. We talk about rejecting hypotheses, null hypotheses in a moment, but generally speaking, the null hypothesis is this: apples fall from higher altitude to lower altitude. And the alternative hypothesis is apples do not fall from higher altitude to lower altitude. And the way you are going to prove me wrong, you're going to actually take me to the zero gravity room from NASA and prove me wrong. That's how you're going to prove me wrong. Okay. Let me stop, and I'm going to hopefully finish. Let me see. I'm going to finish I'm going to take this one and then finish the rest in the next recording. Here, the idea is this. Basically, Band-Aid is going to accelerate healing of the wound. Does that help? Why do we have Band-Aids, and why your mother, your father, your siblings use Band-Aids and bandages and in the hospitals, and do they actually help with the accelerated healing? Okay. What do? You're going to have basically two samples, sample A, sample B. Children there, you're going to use Band-Aids, and you're going to measure the number of days, weeks that the child requires for the wound to heal. And you measure these in sample A, you measure these in sample B, and you see no difference. And that's it. You have actually no significant difference between sample A and sample B. At the same time, what did you say? You said that the bandage or Band-Aid is going to accelerate healing of the wound, right? Your alternative hypothesis is going to be the opposite, and you are going to say the Band-Aid does not accelerate the healing. And you're going to show me an example, and the example you're going to show me is that there is a Band-Aid on a case where I'm going to, after 1 week, after 2 weeks, after 1 month, the wound is not healing. Then you have many questions to ask. Is this person diabetes? Because diabetes are known that their wounds doesn't heal fast enough. Do they have preconditions? Was the wound basically deep? The depth of the wound is going to be important, because as it is deeper, it takes longer time to actually heal. So remember, you are no longer a teenager. You're no longer a 1 year old, 2 months old baby. Your questions are going to be quite interesting. Your employers are actually asking you to be to perform exploration, to be curious, to be a critical thinker, and then come to the table and provide the samples and prove or disprove one way or another. Of course, alternative hypotheses is the main approach. Studying the alternative hypotheses is the main approach in the scientific domain. For example, speaking of you are innocent until proven guilty, nobody is going to go and check your background and say you are innocent or not. Nobody is going to go there. This is almost given as a fact that everybody is innocent. Now, what is it going to be? The person, the lawyer, is going to go through a hell of a job to basically see how to prove that you have committed a crime, or you have sped through a stop line, a stop sign, or red light, and things like that, using evidences such as camera and so on. So keep in mind that in a common sense way, we usually don't want to focus on the null hypotheses. Rather, we want to understand what the alternative hypothesis is, and then examine that. And we do that examinations. There are statistical approaches to do that. We have something called Z-test. We have a student test, t-test. We have p-value. We talk about them as we get there, okay? But it's very important for us to understand what the science part of it is. See you in a bit.